Gil, are you ready?
I am, if you hear me.
Yes, we
Can
hear you
me?
well.
Okay, excellent. I'm currently in my home office.
That is very vague. It seems like you're. Feels almost like you're hiding your location.
Yeah, I'm in Israel. It's summer. It's hot, and I'm feeling pretty cool here in the home office, so that's okay.
It's good to hear you have exactly the opposite problems contrary to ours.
Yeah.
So we've got a couple of minutes before we start, and the track officially starts. So I noticed that your talk has a very Star Trek reference in the title. So are you a fan?
Oh, I'm a big fan. I'm actually getting on my feet to this. We finished with my daughter watching all the series. We're watching the new series. We're reading the books. So yeah, big fan.
Okay, sounds really serious. So speaking of the topic, I noticed that was again browsing around in the background of the speakers, and I noticed that you have quite a long career in IT. So you've been around, and you've probably seen projects both good and bad. So what is your feeling? Are things actually getting better in IT, or are we still going downhill?
Well, the regular me will say we're going downhill. The problem is that it's too easy to create crap and put it out there. The good thing, the optimistic me says that as we go further, people get more mature and professional and understand the impact of these things. And therefore, they're willing to invest in creating more quality. So these are islands, but they are getting bigger. So I tend to be more optimistic with the people I talk with.
That's good to hear. There's the pizza is there and it's getting bigger.
Yeah.
I don't know. Did you follow the rest of the show in the morning? So did you see
No,
the
I
other
kind of missed
speakers?
it. So I saw the last one. I missed
Okay.
the sessions before that.
Because
So the cloud session.
Okay, our first speaker was talking about no estimates, and I noticed that a couple of
Yeah,
years back you spoke about estimation.
I did that.
So it would be quite interesting to hear what you have to say on this topic.
So yeah, I met Vasco a couple of years ago, and we talked about that. I still feel that no estimates is a good approach, but going back to the maturity thing of businesses today, a lot of them are not willing to accept that. So the thinking, the mindset behind it, and the language of no estimates kind of puts a barrier between between the people who actually want to explain why this is a way to go and small experiments and move slowly and small budgets and so on, and why estimates are really not so effective. But again, a lot of businesses are still not willing to like open their ears and experiment with that stuff.
All right. So you will now get the chance to present your topic from hot Israel. So it's a nice. I feel the weather here is getting warmer as well. So probably thanks to your presence. So the floor is yours.
Thank you. So let's see, slides. Yeah, it's the slide. Excellent. So we're going to talk about Spock. Spock is a test framework in Groovy. And I have to admit that I was exposed to that like 3 years ago. and it looked cool. And unfortunately, I haven't met anyone who's using that, including myself. So the talk will be exposing the tool itself, but also the ideas behind it and how you can take these ideas that were put into Spock as a test framework and put them in the tests that you write today, because a lot of the ideas that we're going to talk about is how to write good automated tests and the ideas behind it. So let's see if this works. Yes, it works. So this is me. I'm Gil. I'm from Israel. I'm a consultant. I go to places and talk with developers and testers. Everyone's involved in software development, including product people. We talked about no estimates, so that also comes up a few times. And I work with them to basically create better software, better code. And this is what we're going to do today, because we're going to talk about principles of how to write effective tests and how they embody themselves in Spock. So obviously, you heard Spock, you think Star Trek, and Spock is a test framework that's written in a language called Groovy. Like I said, not a lot of people are using that. And but I'm going to talk about a couple of principles there that are really helpful, both in writing code and in Spock. So we'll talk about that. But this is the only Star Trek reference that I will have, because my examples are going to be from Avengers. I'm not going to talk about why, but the war between the Avengers, the Civil War, is a metaphor for what I'm using to all kinds of discussions. Which kind of testing framework is better? In the Java world, I hear JUnit versus TestNG, or JUnit 4 versus JUnit 5. Everything's basically the same. And the fact is that there's a lot of test framework out there. You can pick whatever you choose, and most of them do the same thing. The problem is that we're not using them as we should, or maybe the proper term is that we're using them as they should, but we kind of abuse their power, and I'll explain. When you take JUnit or TestNG, whatever framework you use, and it's not just in the Java world, it's also in .NET or Python or whatever you do. You get a bunch of APIs and you write them into the tests, and that's okay, but they mix. So I want to show you an example of code, and this is Java code, obviously, and you can see on the top left, like, a test that as I would think it should be. This is an API test, a REST API test. You can see at the bottom right, in implementation of that, this is a Spring service and a lot of services, and the create team really calls the MCU team create API. And as long as the test looks like this, it's okay, because the boilerplate code only have the assert true there. But that's not the problem. The problem is that when I write the code, it looks like this. A lot of the tests that you write will look like this. And when you get tests like this, they do exactly the same thing as the one I showed you. But now you have a lot of boilerplate here. And you need to understand what's important, what's not important, what's happening here, what is the meaning of the sequence, and so on. And you kind of lose the asserts between them. And that's why I'm talking about also in the webinars I recently made about how to write more effective tests. And the thing is that we write tests not just for the fun of it. I know some of us do, but the thing is that we write tests to make sure the system works, but then it's for maintainability. Someone else, maybe us, will get this tests under our hands in 3 months or 4 months or 4 years. We'll try to read this test and look at it and say, do I get what's happening here? And the answer is no. And that's a problem, right? Basically, we write tests to save time. We write tests to make sure the tests are working, and in terms of maintenance, we want to spend as much as possible on bugs and stuff like that. And as tests are more readable, and we'll get them much easier. So I want to take a few steps back in time. So JUnit was the first, almost the first test framework, and the legend says that Kent Beck wrote it on a plane ride in '97, and he was writing it in trying to think of a tool that didn't exist there to try something he called test-driven development, writing tests first. And it kind of worked because there was a test framework. He started TDD, and TDD has a lot of principles in it, but it didn't catch on as much. A few years later, Dan North in England started working on something he called BDD, Behavior-Driven Development. And BDD had the same principles of TDD -1. Dan North didn't want the word tests in there. So he thought that developers are scaring away the product people and the testers, that people needed to be part of the session. And he thought, what can we do? And he wrote a framework called JBehave. And people who work with BDD know that there's something called feature files, and tests are written like that. So it's English, and it has a couple of keywords like given, and, when, and then, not too much. And you write it there, and the developers write something we call glue code. And glue code goes behind the scenes and kind of translates this text into something that operates the system. This way, not just developers can write tests. And this is cool because remember, in TDD, we talk about test first. So product people and testers can write tests up front without the code being there. And they don't need to be part of the incremental part of TDD, which is cool. And we get readable tests, which is what we're talking about, right? So let's talk about what we convene here to talk about, right? We want readable tests and easily to write tests. And this is where Groovy comes in. So Groovy has been in a while in the Java world. And basically, it's called the scripting language of Java. There's a lot of scripts being written in Groovy. It's easier. And it looks like other scripting languages. If you worked with Python, you'll see it's kind of similar. Kotlin has some ideas in there, but it's been there for a while. And Groovy as a language has some principles that go into Spock, which I'll show you after that. So here are a couple of examples in Groovy. What you see on the top left is hello world. You see the main, you see the println, and there are a couple of things to see here. First of all, when we call println, the print function of Groovy, it doesn't use parentheses. And this is the first clue that we have. A lot of what I showed you before and a lot of Java is using a lot of noise there that you don't need. Absolutely, the computer doesn't need it, doesn't need parentheses, but also other people don't need it. So don't need parentheses. You don't need semicolons. Remember, semicolons were invented for parser, for text parser, for the code to be parsed, and it doesn't really help any user to know where the line ends, because the people who write there and the people who read the code know that. So we don't need that either. What you don't see here is, for people who use a lot of Java, know that whenever they open a file, 3 pages of imports are up there. And Groovy brings in something called implicit imports. You don't see the imports, just knows, which is very cool. And these ideas of removing noise is going to be very helpful in creating readable tests. Other things that you may get from other scripting languages, you have it in JavaScript, you have in Python, stuff like that, is type inference. When you have a function like a simple method on the right-hand side of the screen, you don't specify the type. It is inferred from, you see in this inside, a variable is 3. That means it's an integer, therefore we return it, and the function is of a type integer. Again, removing noise. Now, some people will say, and some occasions they will maybe right, that not having these types may create some confusion about readability. But if you think about it, if you have some experience with code, there were a lot less cases when you actually needed it in front of you to know what the type is. A lot of the times it would just be apparent. The other thing here is you see that label, a label with a colon, which doesn't do anything. But Groovy has these labels, and you'll see in a minute how it becomes very important in terms of readability. So here's another example how Groovy does string magic very easily. You can see that in the middle there's a def team status equals creating this string. And it's called string interpolation. It takes the variables that I defined before and kind of sticks them in the string. If you know Java, you know how it would look like in Java. You'll have to concatenate, and sometimes you'll have to cast it, and maybe have a string builder do this for you, and create a lot of code that you don't need, which Groovy just gives it to you. The other thing you see at the bottom is the assert word. The assert word is part of Groovy. Basically, it's not needed. So if I just drop the assert here and write just team status equals the string, it will break if it doesn't work, and that's very useful for tests. Final thing I want to show you in Groovy, but is very helpful in every test you'll probably write with APIs, is Json. Because we all write with Json, it's their way to work with. And you'll see that this Groovy comes something with called a JSON slurper. You can pass it some kind of JSON strings, and you see that it tries to create an object model that's very useful. You see that cap, which I put the JSON in, is a map, like every JSON. So it's kind of created a hash map for that. And you see that cap.name, which is the key in the JSON, brings you the value. If you worked with Python, you know that you can do the same thing with indexers, but this is much cleaner. So you have this, plus you can pass in, it identifies list, and it casts the things into integers, as you see at the bottom row. So it creates a lot of shortcuts that are easy to use, and therefore you'll write a lot less code to achieve them. I didn't mention this. Groovy runs on the JVM, so that means you can write Groovy that interacts with Java code, which brings us to Spock as a framework. Spock as a framework is built in Groovy, and you can write tests in Groovy and in Spock that run your JVM code. So whatever you're writing in Java, Kotlin, whatever, we'll run it. You don't need to rewrite everything. So let's take a look how tests are starting to look like in Groovy and in Spock. What do we see here? First of all, this is a unit test, not a REST API test like we did before. So it just works with the objects. It doesn't do with the API. So what you see here as add member, it's an actual method on the Avenger. So on the top, you see the same thing that we saw before. But what is apparent here are two things. First of all, look at the name of the test. It is a string. So if you worked with JUnit and you have a display name or whatever test framework you have, you don't need to write it twice. Write it in the string, and it will just be the name of the test. Very easy. Well, why didn't anyone think about that? Second thing, you have the given, when, then. We talked about the labels that you have from Groovy. That makes things a lot easier. Because if before we did that separation between paragraphs of code to say, well, this is the setup, and this is when you actually execute the code, and this is when we do the asserts, get the labels. It's much easier. Plus, you see at the bottom, I told you that you can use assert, but you don't have to. So the assert at the bottom is equals, assert equals, that we all know. Why do we need the words assert equals there? Much easier and easier to write and easier to read. So this is very cool. Here's another thing. Now, whatever framework you're using today has something called parametric tests or data-driven tests. So you pass it. The idea is that you write the test once and you run it multiple times with a set of parameters. Now, if you use JUnit 4, that was horrible to set up. It wasn't readable. You had to create a separate class for that and so on. JUnit 5 is much better than that. TestNG is better. But look at this. Look at what we have here. I'll get back to the test name in a minute. First of all, we have the given and expect. We talked about given, when, then, but given and expect are also similar in that given setup, expect is the assert. So that comes from before. But you see the where at the bottom. You see a table with pipes like the name and the results, which are the names of the parameters. Name is 3 cases, Tony, Captain, Thanos. The results for each one is true, true, and false. And that's basically it. If you're familiar with something called fit and fitness from something like 20 years ago, which was kind of the first end-to-end automated framework, it worked like that. You would write like a table in text, and the parser and the runner will interpret that. So writing the where in terms of a table, it's very easy to do. Obviously, you can write multiple columns here. And what it does, it embeds the name and the result whenever it runs the code. But just specifying the tests is cool. But look at that. Look at the name of the test. It is placeholder for these parameters. So you kind of embed the test parameters in the name of the test. And this is what you'll see in the report. How cool is that? Again, it's not groundbreaking, but it becomes much easier to use with a lot less code to type. You want to add another type? Sure. Another test case, write it at the bottom. It will just run it again. Mocking. So everybody working with the JUnit, TestNG, whatever, knows about Mockito. So Spock actually has a wrapper around Mockito for that. You can see it, how we can do that and how we specify what the behavior that we want to do. So the setup is on the left-hand side. I'm just creating a mock. It will know exactly what type. You see on the right-hand side of the screen on the first test, we have the setup label, which says mockhammer.canLift, which is a method I want to change the behavior. Couple of triangles, true. That's it. Mockhammer.canLift. True means exactly like when mockhammer.canLift, then return true. Easier, faster to write. At the bottom, on the bottom test, you have the same thing, but something that's equivalent for then answer in Mockito, which is running a code when the canLift method is called. So you can specify that as well. Look at the bottom thing. So we at the top test, if you could just zoom in the code again. Yeah, thank you. So on the top one, we have the assert, which is cool because canLift is Boolean. But at the bottom, look at what we have. First of all, the first line with the bang, Tony can't lift mock hammer. Everyone who knows Java can understand that this is assert not. Assert not equal or assert not true or assert false. Cool. The line behind that, at the bottom of the screen says mockhammer.lift, which is another method that mockhammer does, was called 0 times. Now, if you know Mockito, you'll know that it's going to be specified like verify mockhammer.lift times 0 or never, whatever. Much more concise, much easier to write, and it conveys the message a lot more. Okay, I want to get back to conclude this with the test I started with. So Spring runs on the JVM, therefore you can write tests for it. And what you're seeing here is Spring Boot Tests API, of course, with a mock MVC and stuff like that. So I showed you at the beginning how I would write this. And this is hard to Groovy size. But if I use Spock again to use it, it would look like this. And this is what I haven't showed you. Given when and then can get also strings that will come out in the report, and it allows you to write comments as well, because basically they don't compile to anything. So it will come back to having the mental state of, I want to write a test that reads great. Someone from English. Now, the BDD, I wouldn't say it failed, but the major failure was creating two layers, the feature files, which is a text, and the glue code. And this is Spock. And if you heard about Serenity, another framework from the Java space, they do this. They combine the two things so we can write tests in proper English and tell the story, and much easier in one place. But it's still our job to say we want to write tests like that, otherwise they won't. So let's conclude. Like I said in the beginning, I haven't seen anybody using Spock. And that's okay, because I'm not sending you to throw away whatever framework you're using and use something that nobody else is using. I want to tell you that whatever you do in Java, in other frameworks, you can create code that looks like this. You can also use tools that make things much easier. If you say, well, I'm not tied to JUnit, next test I'm going to write with another tool, that's okay too. And you get the benefit and you get the mindset of a framework that says, I don't want to give you tools to write tests. I want to give you the tools to write readable tests. And that's great. This is what we want. So we come to the end of this session. Like I said, it's a tool. You can decide to use it. You can decide to try it. I really recommend that. What I showed you and will be on the screen in a minute is examples from a GitHub project that you can download and try. Basically, you get the Groovy libraries and Spock libraries. And the examples, it's a Maven project. That's basically it. And try and be open to other things, because if we look around, we'll see that other people created tools, languages, whatever we can use, because they had other ideas in mind, not just make code work in production, which is very cool. And that means we're into question mode, so we can take questions. Before that, final things to show you. This is where you can get the code, github.com/Gil Zilberfeld. You have all my projects there, and you can contact me, whatever you see on the screen. And that's basically it for today. So if there are questions, let's see them.
Thank you very much, Gil. So yes, we do have questions. And first one is which role or who usually writes the behavior-driven tests? And after that, when is the right time to do it?
So I worked with different teams that work differently. I worked with a few, like 5 or 6 years ago, with a team that the testers and the developers worked together. The testers at the beginning of the sprint wrote the feature files, and they gave it to the developers. The developers wrote the glue code, and by the end of the sprint, they'll have tests running. So that's where the testers wrote it. I saw teams of developers writing it, although this was kind of, I won't say stupid, but if you're already writing, if the developers are writing the tests, write them in a language that they know, rather than write them twice, like in feature files and then in glue code, and then have the product people review them so they know that it's okay if they did that already. And I had not enough cases of the product people actually doing that. So they wrote like examples of things are working in feature files, which later got expanded to developers. When should they do that? Hopefully, in the BDD mindset, before writing the code. Otherwise, it's kind of like documenting the code that's already there, right? Writing test after, which people find a lot, both developers and the product people find kind of superfluous. It's already working. Why do we need that? We can just document it in a Word document, and everything's going to be okay. So that's how I feel when people use it, and the right people can use it. So the people who are not familiar with software, they should write it before the code is written.
Okay, always nice to have working code in production in the end.
Yeah.
Yeah. So next question is that what is most important to get team ready to use behavior-driven development and testing?
Okay, so well, that's a very big question. Usually when you introduce behavior-driven development, even for a team that does automated testing, and especially if they don't, you need to understand that they're going to start writing software or producing software in a different way that they have until now. What that means is that you're going to have objections, and it worked until now, why should we change, and all these kind of things. Okay, so the most important stuff it actually divides into two. First, you need some kind of agreement that we're going to try this new thing. Hopefully it will work because it worked for other people. The next thing, which is more important, is to have managerial consent to do that. Because if the team decides to do it, but their top manager, the CTO, decides we're going to let them play with their new little game, but I know that they will fail, and if they ask for more time to learn stuff, I'm sorry, but production is more important, it will fail. So whatever works might stay, but a lot of people will just joining with, well, we can't do that. It probably works for other people, but not for us. So an agreement in the team, whatever the size of the team is, to go forward with that as an experiment, and managerial push, or at least consent, that we're going to try that and let it fail. That's great, but we're going to try that.
All right, thanks. So next one is the testing code part of the product code. So and how do you keep the consistency with the product code? So, for instance, do you create tests in the same feature branch, or do you create tests in separate branches? How do you handle that?
Okay, so first of all, the mindset. we need to consider the test code as production code. That's the beginning. If we don't, a lot of things that we see today, unreadable tests, not enough coverage, all comes from the idea that tests are second-rate code, and therefore, if we have time, we'll get there. We will do the minimum that we'll write in order to have them just running. We'll not fix them if they fail. The whole mindset needs to change. Second, a lot of it comes from how the tooling works. For example, if you want to write unit of course, but automated API tests and so on, you'll need to reference libraries. Now, you can get them wherever you want, but if they're in the same projects, it's much easier to get the latest version or the current version, whatever you're using, because the tools help you do that. So a lot of that comes from convenience. If it's convenient, people will do it. If it's not convenient, they will not do it. Do I need to deploy the test projects? Probably not. But if you look at open source history, ever since the late 90s, a lot of open source projects were deployed with their tests. So when people get them and they try to modify, they will be able to run tests. So that's not a big problem. You have to decide what you're doing to do, if there are security risks and so on. But usually, the test code is kept separately, but probably inside a project. But whether it's deployed, it's a question of what we want to achieve by that and what are the risks. If there are no risks, I say deploy everything. It's much easier to create testing scenarios if something doesn't work in production, because it's going to be in production where you're trying to reproduce stuff, not on your lowly machine in the only machine that is limping in the cloud just for you.
Thanks a lot for the extensive answer. So it looks like we're running out of questions for the time being. Thank you very much, Gil, for joining us.
Great to be here. Maybe next time in person. Hopefully.
Yeah, at the moment, I'm feeling more and more confident that next time it will be an actual conference with actual people and actual food, which is coming up next. So thanks a lot. Now we are moving on to our lunch break. So this time lunch is on you. Next time I hope it will be on us. And we have time until 1:30, and then we will take it from there. Thanks a lot and see you soon.